Okay, we're ready to go. That's kind of amazing. My last class today was at 10 o'clock. Of course, got done at a little before 11. Anyway, I'm recording my classes, and I thought I'd give a shot at this process. You got to do this video processing in order to make these video recordings small enough so they can be put on the web. So I thought I'll give it a shot. We'll try processing that video from that class and see if I can get it done before 12:30. And the reason I have to get it done before is I got to have that done before I start this one. Well, it ended exactly at 12:30. Basically took an hour and 20 minutes. Anyway, that's half the problem, getting these things processed. If I haven't told you already, I am in the process of catching up. This weekend I should be caught up. And then my goal is each evening to have up sometime before I go to bed that night to have the video up from that day. I know you wish it could be up immediately, but it can't. It takes a little while. And then I have several. I'm doing it with almost all my classes. So anyway, bottom line is, starting this weekend, everything should be starting Monday, everything should be caught up. So Mondays will be up. So today we had 2.2. Open that up to questions. Anything you'd like to work through? Oh, before I forget, I should show you this. I have my first projected schedule for you based on where we are and where we're headed. Today, I hope to do lesson 2-3, Venn diagrams, which we've already talked about a little bit. That would leave Monday for lesson 2-4, which is called the number of elements in a set. I haven't told you this yet, but lesson 2-5 in the book we're not going to do. I'm going to replace it with a presentation that I'm going to give you called the Two Infinities. So I'm planning on that being next Wednesday. So that means the last lesson, so to speak, will have been taught by Wednesday. That means Friday of next week, we will have what I call Review 1. That day you'll get a chance to ask questions about lesson 2-4. And we'll have the first review for the chapter. I follow it with another full class of review on Monday. And so a week from next Wednesday is when I project the first test to be. That's the bottom line. And I just wanted to show you where I'm headed. It's my roadmap. Should be pretty accurate. So that means on Wednesday the 6th, you want to have your first notebooks ready to be handed in also. Has everybody got their 3-ring binders? Is that all taken care of? Probably should jump on that right away. We don't want to leave that to the last minute. Any questions about where we're headed schedule-wise? So the first big grade events, notebook is pretty big, and so is the first test. Okay, questions on 2-2? Yes. 29. Let's see. Directions. U is some universal set of which A is a subset. In each case, find the indicated set in terms of A, U, or the empty set alone. Okay, what's the complement of the empty set? Well, what does complement mean? It means kind of everything else.
Oh.
And so,
Okay.
if you're at empty, and I tell you to do everything else, where are you going to be? Everything, and so you're going to be that script U universal set. Yeah. So it's kind of like an inverse thing.
Okay.
Another one? Yes.
53.
53. In 53 and 54, verbally describe each specified set. And now remember, maybe you didn't see this, but they defined the M and the D and the F and all that kind of stuff in down at the bottom of the previous column. Okay, M is what? A set of males who are employees. And D is the set of employees who work in the database, data processing department. So what does M intersect D mean? People who are both male and who are employed in the data processing department. No, union is either or. It's one big happy family.
But intersect isn't the
What's in common?
of both, but
Right.
wouldn't that just like
No, I see what you're doing. You're being a little too literal with the words. Think about it this way. M was what? All the men who are employed at this company. And D was all the people who are employed in this data processing department. So what's the overlap between those two? Just think about it in common sense now. Wouldn't it just be all the men who work in the data processing department? So I know what you were doing. You were looking at words that said which words are common. In this case, because those weren't in brackets, you don't want to think literally. If they were in brackets, then your thinking is exactly correct. Yeah, I could see where you were a little bit, it's easy to get misled like that. Good questions. Another one? Yes. 49? Let's see. Find S1 complement relative to the universal set found in problem 48. Okay, well, we got to go back and do 48, otherwise we aren't going to get it. Do you see that? So what's 48? What's the smallest set that will serve as a universal set for S1 and S2? Okay, S1 and S2 are those two columns, aren't they? Up there, aren't they? So, what's the smallest universal set that'll work? Well, I need at least one of everything, right? So I need encourages, suggestions, sets goals. I need everything in the first one. Encourages, suggestions, sets goals with me, gets me to have high goals, listens carefully, is aware of others, is self-aware. What do I need yet from the second column? Follows up on action. And that's it. Got it? So that, excuse me, if I set up a universal set with those 1, 2, 3, 4, 5, 6, 7 things in it, now do 49. What's S1 complement relative to that universal set? So what they're asking you is, what's not in S1 that's in the universal set? And isn't it just that one thing we added follows up on action? Does that make sense? Not completely, huh? See, if I didn't want to, what we should have done is made that list. And then said, okay, in this list, which ones aren't in S1? And the only one we added when we went to the second column was follows up on action. So that's our guide. So what does it mean when they say find S1 complement? Find, are there any others that are not in the first list that are in our universal set? Yeah. Another one? Yeah. So lists. Are lists sets now? Yeah, really a list is a set. And so if you sit down and what are the things I have to do tonight before tomorrow? Really it's a set. It can be thought of as a set. Any others? You know, we use sets. You've used sets your whole life. You just haven't thought of them probably very formally up until now. Turns out to be a very powerful line of thinking for problem solving. You know, for example, let me just give an example. Let's say we wanted to do, and this is a lot like your question. Let's say we're watching a show. There are tons of them now that what? Are into crime solving. Most of them are using a lot of techniques with high-tech equipment to do DNA tests, and they got all these cool fluorescent things that help them find fingerprints that they wouldn't normally find, and blood, and all that kind of stuff. Okay. So let's say they find out from their evidence that, I don't know, they found something that leads them to believe that the person lives within a 5-mile radius. I don't know what it is. Maybe a bike that they're positive the guy rode in. I'm pretty sure he didn't ride it more than that. So they've got evidence of that. And then, on top of that, they're pretty sure he took a cab from a certain cab company because the cab driver said he saw him. So now, put those two together. So we got a suspect who we know came from a 5-mile radius, and we know he got in a cab by, I don't know, Acme Cab Company or whatever. Okay. Wonder where those two sets overlap. Where do they intersect? In other words, if we could find all the people who live within a 5-mile radius and took a cab from Acme, now we've narrowed it down to that overlap section where the two circles overlap. This kind of thing is done all the time. And then if they find a third clue, like, oh, now we know what happened after 11 p.m., you keep narrowing it down to a smaller area, and it's a great way to solve crimes. It's a great way to solve problems, too. You kind of just keep narrowing it down until you only got one thing left. Okay. Anybody else have a question on 2.2? Lesson 2.3, we've already started a little bit on. I guess I spilled the beans last time a little bit, because every time I taught you one of the new operations, I showed you a diagram right away. So this won't be totally new today. Those circle diagrams are called Venn diagrams, and I'll show you a guy that, well, here he is. Well, first of all, here's the title of the lesson. And that double N, that's because it's named after, and you notice sometimes they're called Euler diagrams. I wrote that on top, E-U-L-E-R, it's pronounced Euler. They're both men's names. You're going to hear more about Euler. And then, a Brit, as you can see, his years there, he's the guy that came up with these diagrams first, and that's why we call them Venn diagrams. So, let's review. Yesterday, I taught you what? What are the operations I taught you last time? The upside-down horseshoe, which is called intersection, and how would you describe it?
Things that only are wherever is in both sides.
Yep. Anybody think of another way to say it? That was perfectly good. I'm not looking for improvement. There's another way to look at it too. Isn't it kind of like what's in common? And another one might be where they overlap. I'm sorry. That's what you were going to say. Yeah, just like what we were talking about earlier. Okay, what's the next? I'm doing these out of order, but the second one I think I taught you last time was when the horseshoe is opening up, and that stands for union. And how would you describe union in your own words?
Combining all the elements of a set without duplicates.
You bet. Combining without duplicates. Very well done. And then, I don't know if that was the next one, but going down, you see I have a complement. And do you remember, in your own words, what's a complement? Let's see, that came up in the question. Yeah, your question. You asked me about a complement. Could you describe what a complement is in your own words?
Complement is everything else.
Yep, everything else. Or sometimes it's like not, where you say something and you put a not on it, it just means what? The opposite. So if it's not in it, it's everything else. Again, it's not. Do these pictures, agree with what you just said? So for example, if A is that circle on the left, I know the red is a little too dark. You probably can't see, I have another circle there. But anyway, if A is the circle on the left, does that red area appear to be a complement to you? It's everything outside of circle A. And of course, not everything, because it doesn't go forever, but that's because the boundary we always use is the universal set. Does intersect look correct? Just the overlap? And how about union? Combine them, and no double coverage in the center, just once. Okay, good. Okay. I have a new, very important thing to teach you. It's called De Morgan's Law. But before I can teach it to you, I just made up some sample sets again. I always got to use samples, otherwise it's hard to illustrate. So I made up a universal set of the numbers 1 through 7. And then I decided to call set A 1, 2, 3, 4, 5, and set B 4, 5, 6. Okay, here's De Morgan's Law. I guess you could call it A. There's two versions of it. They both say the same thing. If you do an intersection and then take the complement of that whole thing, that's the same as taking the complement of each one of them separately, but not doing an intersection, doing a union. So just take a look at this. Do you see? It's almost like a distributive property. This complement got put on both of these, just like you'd expect, but please note this is reversed. It was an intersection symbol, and now it becomes a union. Now, let's illustrate that it works. So take my example and let's try it. What is A intersect B in my example? What's in common between A and B? Does this look right? 4, 5? Those are the only two things in common. What's the complement of the set with 4 and 5 in it? What's everything else other than 4 and 5 when you look back to the universal? 1, 2, 3, 6, 7? Does that look right? Okay. Now, let me prove that the other way works. Comes out the same answer. What's A complement? Just the 6 and the 7. What's B complement? 1, 2, 3, 7. And what happens when you do the union of those two? 1, 2, 3, 6, 7. And you notice how we arrived at exactly the same place. So now, I haven't proved anything to you. I just showed you that in one case it works. Well, we're not going to do proofs in here. But guess what? This works every time. Otherwise, we wouldn't call it a law. It also works, here's kind of version B. Instead of starting off with an intersection, you can start off with a union. So what would happen if we do A union B, and then take the complement of that? That's the same as, again, taking the complement of each one, and this time reversing this guy. Instead of it being a union. So it's really the same law. We just wanted to show you that it doesn't matter if you begin with a union or with an intersection. Okay, this is going to keep coming up. I'm going to warn you many times. Okay? So you've got to understand this. Otherwise, I don't know, I was just looking at some of my previous tests on chapter 1. And this law probably affected 5 or 6 questions on my test. And my test only had about 20 questions. So this is a biggie. Okay? Whatever you do, don't miss this one. Highlight it, do something, make sure, and don't forget, please ask if you don't see how it works. But we'll get a chance to practice it some more too. Okay? De Morgan's Law, by the way, named after another logician. Augustus De Morgan. And by the way, I think just to add, let me just load my WLC. I wanted to show you something about the website that incorporates these people. You'll notice, well, I don't have De Morgan, but you notice how I have a picture of Euler too. I didn't have that before, and I also, and there's John Venn. And if you click on that, in case you're interested more in their history, that appears. Okay, so sometimes I'll even do that in the on the MyWLC site. Sometimes I'll put a couple historical items like that. Will I ask you about things like that? Probably not, but I just thought you might want to look into that. All right. Back to, okay, yeah. Now, new and challenging. So, well, De Morgan was new. Here, I'm trying to think of exactly what my diagrams are trying to be pointing at here. Hang on just a second. I think I was trying to illustrate graphically that De Morgan works, but that's not a real easy thing to illustrate. Well, I'll try it anyway. Let's see if this illustration is good for this. Again, what does this say? Take A and B and join them together, and what do you get? The white area up here, right? Which is kind of what? I'll refer to that sometimes as the inside of the MasterCard symbol. Okay? Then if that's what A union B is, what's A union B complement? The red part, right? Okay. So you see how that makes sense. Now, what does De Morgan say this is equal to? Remember? Here it is right here. It says A complement intersect B complement. Okay. Now, yeah, I guess I'll just do it on the board. I'm not sure my diagram does it on there. Or I'll just make a new slide here. Okay, let's just say, let me try to show you this illustration this way. So if this is A here, and this is B, where is A complement? Everything outside of A, right? What I'm going to do is try to, it's not going to work real well, but I'm going to try it anyway. I want to try sketching in what A complement is, and I'm going to do it by shaded lines going, parallel to each other. Kind of a corny way of shading. You follow me? But of course I can't shade in A because it's A complement, so it's everything outside of A. So does this look like A complement to you? Not done yet. It's going to take a while, but you get the idea, I think, right? Let me get the rest of these. Okay, A complement. Kind of goofed up on the last ones. Now, where's B complement? Okay, that's everything outside of B. Now I'm going to purposely shade on a different angle. In fact, why don't we change colors too? This time, I don't know, change to green or something. Okay, so I'm going to try to shade everything outside of B now, and I'll try to go on this angle. It's kind of like kindergarten, you know, you're not supposed to color outside the lines. I've already made a crossed over, haven't I? A couple places. So would you agree if when I get done here that that's going to, the green shaded area, would that be B complement? Okay, and now I have a question for you. Where do A complement and B complement overlap? Well, shouldn't that be where the two shadings make crosshatching? And where is that result up here? Isn't that the outside of the MasterCard symbol? Can all of you see that? Now, if that's, so what I just drew a picture of here is, this is A complement intersect B complement, right? Now, let's look back. Does everything outside the MasterCard symbol answer agree with? Sure enough. So now we've finished a little pictorial view. Hey, De Morgan really works. Okay. Here's a new one. Or no, I guess this is review. Do you remember the bouncer? The set difference thing? And that's like getting thrown out. So if we have set A, throw out everybody in set B. Wouldn't you start when you do A, you have this whole circle filled in, but then the bouncer comes along and throws out all the B guys, and you wind up with this little cavity here, right? Okay. And here's the opposite. What if we did B, set difference A? Start with circle B, take out the A, that would look like this. Okay. Scroll down here a little bit. Do you remember what that horseshoe means when it's turned on its side? You know, like, sorry, this is pretty ugly here, but that big horseshoe is supposed to be aiming to the right. That reads B as a subset of A. Do you remember that? And I tried to draw a picture here where B is a subset of A. Does that look correct? Oh, we got a bunch of visitors. Of the little variety. So B is a subset of A, right? Now, do you understand this statement right here? In this picture, in this context, where B is literally surrounded by A, does this make sense? Because what does it say? It says where A overlaps B is B. Right? Isn't the overlap just right here? And so here's a unique, just a unique little characteristic. What happens when you intersect a set with its subset? You get the subset. I don't know if you, I wouldn't memorize that, but I just want to see if, can you see it? Okay. Okay. Now these are kind of fun. Page 70, this is from. That doesn't sound right. That does not appear to be the right page. Yeah, it looks like it might be 77. Thank you. Yeah, except that the numbers are different. Well, I'm not sure what I was doing here. Let me just say this. Sometimes what we'll do is when we solve sets, because you can go a little bit crazy with all these cross-hatchings going all different directions, it gets way too crowded. So sometimes instead of doing that, what we'll do is just number the regions. And so sometimes we'll just call this little region in the center here, region 1. And I don't know. Just beware that sometimes there are some problems that do that. I'll tell you what, I'm going to peek ahead at the assignment. Yeah, okay. Let's take a look at, open your books up to page 80. I see a problem similar to this. And I'll erase and we'll just use that. Okay, everybody, do you see the bottom of page 80, first column? Do you see a diagram there? And they've got the regions numbered. Let's see if I can copy the regions properly here. You have 1, 2, 3, 4 down here, 5, 6, 7 in here, and 8 on the outside. Okay. Now, using that diagram, can you do some of these problems? All right, so instead, you can do these with region numbers also. So I got to do one more. Give me a second here. I got to redo this a little bit. So what I'm going to do is grab this, group it, copy it, start a new page, paste it, make it smaller. Okay, now I can do this problem. Okay, let's do number 10. Number 10 has this for the problem. They want you to do C intersect A union B. So here's the problem. And as you know from yesterday, what needs to be done first? The part in parentheses. Now, instead of, so which regions are in A union B? So I'll tell you what, let's do it this way. Which regions are in A? 1, 3, 5, 7. Doesn't matter what order they're in. That's A. And B is 2, 3, 6, 7. And what happens if I do the union of those two? Join them together, no repeats, so what do I get? Does that make sense to you guys? Did I do it right? 1, 2, 3, 5, 6, 7. Notice I didn't repeat 7 and I did not repeat 3. And where did I get that info from? I got it literally from the diagram. Okay, now what's in set C? Well, it's just 4, 5, 6, 7, right? So here's your last step. Looking back at the problem, I need to take this guy and intersect it with this guy. What's in common between those two? Is it 5, 6, and 7? So it's a sets problem, but instead of having elements written out this type inside of braces, this time they told us what was in the set kind of by region number. And so do you see how you can do sets problems this way? You're going to have to do some like that. I'm sure that's where I was headed there. Okay. This one we already did. Okay, let's look at this example. This is number 8, I believe, in this assignment. Yeah. Number 8, the directions are draw a Venn diagram and shade the region representing each specified set. And they wanted us to do A union B, set difference A. Well, first, what do you get when you do A union B? Think about the parentheses first. A union B. The two circles are joined together, and I kind of get this inside of the MasterCard symbol thing, right? Now, remove all the A's. And what's left? Wouldn't it be that shaded area? Everybody see that? Okay. I'm just trying to give you guys practice and samples here. Let's do number 13. Only let me erase this so we can do it over again. So here's our problem. Here's our diagram with all of our regions labeled. Okay, this time we're supposed to do A union B complement, take the answer to that, and intersect it with C. So let's first, what's in A? Which regions are in circle A? 1, 3, 5, 7. Now, let's see if you can do this. What's in B complement? Which, in effect, I'm asking you, which things are outside of circle B? And don't forget about this one out here. 8, do you see that? Okay. Now, I'm supposed to take the union of those two. What do you get? Sorry, this is a little sloppy. We got a 1, we got a 3, we got a 4, we got a 5, 7, and an 8, right? Does that look good? Now we're supposed to intersect that with C. And what's in circle C? 4, 5, 6, 7. So now you've got to do an overlap. What's in common between these two? 4, 5, and 7, right? Okay, we got another one of those in. Here I just wanted to show you that Venn diagrams are used very frequently. These are actually illustrations that I took out of Nature magazine. Nature is England's top scientific magazine. If you're wondering why I'm in there, it's because they give me that one free. And free is good, especially for a cheapskate. So anyway, it's their top publication. So I go in there, and I just wanted to show you, look, here they're doing some kind of scientific study, and they're really interested in where these sets overlap. And what do they use? Venn diagrams. Here's another one studying DNA. And I don't know if you remember, but DNA has these letters coding. And again, look at what they're looking at. Where do these things overlap? And Venn diagrams are just perfect for classifying things like that. Okay. That should leave us to the point of some kind of an assignment. And here it is. Assignment, section 2-3, a little bit complicated. Here's the beginning, 1 to 41 odds. Except for one thing, I'm telling you to skip number 39. 1 to 41 odds, don't do 39. Why don't you, since we have a little bit of time, let's just get rolling on that. I'll probably let you still go early, but let's get some of it done, and then you can certainly communicate with each other, call me over, ask me questions. 1 to 41 odds, don't do 39. Yeah.